Hello, this is Christian here. In this video, I'm going to do some of the problems of your homework number 3 and the first review. I'm not going to do all of them, but I'm going to do the problems that I think might give you some trouble when trying to solve them, okay? So the first problem is a homework problem, and in this problem, we have to find the sum of the measures of the angles A through F, okay? So here, we have 3 triangles, and we don't really have much to work with, okay? I'm going to call this angle right here, I'm going to call it by alpha, this angle by beta, and I'm going to call this angle gamma, let's just say, okay? Now we know, for example, that if we add A plus B plus alpha, the result has to be 180 because the sum of the interior angles of a triangle is always going to be 180. The same applies for this, this, and this. If we add those 3 angles together, we're going to get 180. And the same for the other 3 angles, this one, and this one, okay? So we're going to use that, okay? So we know that if we take the sum of all the angles, including the ones in green, we're going to get the following result. So we know that if we take A plus B plus alpha, let me group them over here, plus, let's say, C plus D plus beta plus, let's say, E plus F plus gamma, the result of that big sum is going to be, so here we have 180, over here we have 180, and over here we have 180 as well. So we're adding 180 3 times, so the result of that has to be 540 degrees, okay? Now we don't want this big sum, okay? Wait a second. So we don't want this big sum, we only want the sum of the angles A through F. So we somehow want to get rid of this angle, this, and this. So now the question is, what is the sum of alpha, beta, and gamma? So if we know what alpha plus beta plus gamma is, we can get rid of all these 3 terms over here, and then we simply subtract by their numerical measure on the right-hand side, okay? So notice that alpha, this angle over here, is essentially formed by this line in green and this line. And this line, okay? So that means that this angle over here is opposite to alpha, and we know that opposite angles are congruent. So this angle has to measure alpha as well. But now notice that we have alpha over here, this is alpha, this is gamma, and this is beta. And notice that they form a straight line, okay? So we can say, well, alpha, beta, and gamma are supplementary angles. So alpha plus beta plus gamma has to be equal to 180. And again, the reason for that is because if we add the 3 together, they're going to form a straight line, okay? So now, if I subtract alpha plus beta plus gamma on this side of the equation, on the left-hand side, we're going to have to subtract 180 over here. So we're going to end up with A plus B plus C, remember that we're getting rid of alpha, beta, and gamma, plus D plus E plus F, and this is going to be 540 minus 180 over here, which is going to be 360. Okay, and that is our solution. So the sum of all the angles A through F, ignoring beta and gamma, is going to be equal to 360. Okay. Now, in the second problem, you have to show that opposite angles are always congruent. Okay, so here we have 2 lines that are intersecting each other. Okay, and what you have to show essentially is that B and D are congruent, or that C and A are congruent, okay? So I'm just gonna show that C and A are congruent, okay? And then you can follow basically a similar reasoning to show that B and D are congruent. So the first thing that we're gonna observe is that if you observe A and B, these two angles form a straight line, right? So they form a straight line over here. So they're supplementary, okay? So we can say that we know that if we add A plus B, we have to get 180 degrees, okay? So that's basically adding these two, okay? So now by similar logic, if you observe B and C, the sum of B and C is also 180 because they form a straight line, okay? So also, the sum of B and C has to be 180 degrees, all right? So if this sum is equal to 180, this sum is equal to 180, that means that they have to be equal to each other. They measure the same thing. So A plus B has to be equal to B plus C. But now notice that we have B here and here, so we can cancel it out. And we end up with the equation A is equal to C, which essentially shows that this angle is measures the same as this angle. So therefore, opposite angles are congruent. Okay. Okay, and you would need to show also that B and D are congruent, or they measure the same number, but you can follow a similar logic as we did over here. Okay. All right, so in problem number 3, this is a problem from your review. I believe the angles that you had initially was 70 over here, which I forgot to write. And I forgot to add another line, so let me just do that over here really quickly. So this one had to be 68. And we were also given that this line and this line are parallel. Okay, so over here, we have two parallel lines that are cut by two different transversals. So you have this one over here, and you have this one over here, okay? And you are given these two angles, okay? So we can know a bunch of angles already, because if you notice, if this measures 70, this is opposite to that angle, so this one has to measure 70 as well. This one is opposite to the 68-degree angle, so this one has to measure 68 over here. These two lines are parallel, okay? And this line is a transversal of those two parallel lines, and 68 corresponds to this angle over here, and in this scenario, they are congruent. So this has to measure 68, and this is 68, okay? Now, this angle, when added to 68, you get 180 because they form a straight line. So this has to measure 112, okay? The same goes over here. This has to measure 112 as well. This one has to measure 112, and this one has to measure 112, okay? Now, to know the other angles, first note that we have a triangle that has been formed over here by those two lines, and then one of the parallel lines. And we know that the sum of the interior angles in a triangle is 180. This angle has to measure 42, okay? That's the only way those three angles are gonna add up to 180, okay? So if that angle measures 42, this one measures 42 as well, because this one is opposite to this one. These two form a straight line, okay? So this has to be equal to 138 in order for this and the 42 over here to add up to 180. These two lines are parallel, remember? So this angle corresponds to this one. And in this scenario, they are congruent. So this is 42. This has to measure 42, this 138, and this, and this one 138. Okay, and we have basically found all the unknown angles. Okay, so with only 3 facts, only knowing this angle, only knowing this angle, and the fact that these 2 lines are parallel, we were able to find all the other angles. Okay. All right, so in problem 4, you have to prove that the sum of the interior angles in any triangle is equal to 180 degrees. Okay. So there are at least 2 ways that we saw in class to prove this result. I'm just going to do one of them, which I think is the easiest one. And in this strategy, you have to select first one of the sides of the triangle. So I'm just going to select this one, let's say, the one on the bottom. And you want to create a line that is parallel to this side. Okay, so I'm going to do the line as follows. So let's say the line touches B, or this vertex right here. I'm just gonna draw a line like this. You can think of this side to be extended as well. And now these 2 lines are parallel. Okay. Now this is gonna help us a lot because now we have 2 parallel lines cut by 2 different transversals. So one of the transversals is this one, and the other transversal is this one. Okay. Now if we work with the purple line, notice that A and this angle are opposite side interior angles. Okay, so they're opposite sides because they are on opposite sides of the transversal, and they are interior because they are in between the 2 lines. And in this scenario, these angles are congruent. So this one has to measure A. Okay. Similarly, this angle over here has to be congruent to C because this is an opposite interior angle to this one. Okay. So now notice we have B over here, and we have A and C, and they form a straight line. Okay. So this means, let me just circle this part over here. This means that A plus B plus C is equal to 180 degrees, which is what we wanted to show. Okay. All right, so let's move on to the other problem. So this problem was the most troublesome in our review, okay? And I'm gonna show you 2 different methods for you to solve this problem. One of them is more intuitive than the other. And visually speaking, it's more intuitive. So over here we have 2 lines that are parallel, okay? And we have 2 lines, we have this one and this one that are almost transversal, but not quite, right? Because we only get to B over here. But I'm just going to imagine that I can extend one of the lines like this, okay? And now this line, let me maybe do it in purple. This line is going to be a transversal of the parallel lines, okay? So notice that this angle over here is opposite interior angle to C over here. So it has to measure C as well, okay? So that one measures C. All right, and now notice that we have formed a triangle over here by simply extending one of the lines, okay? So now we have a triangle over here, and we don't know the numerical measures of this angle, this one, and this one, but we're interested in finding the sum of A, B, and C. Okay, so we're gonna use that to our favor, okay? So the measure of this angle, notice that C and this angle over here have to add up to 180. So the angle inside the triangle has to be 180 minus C, okay? So it has to be 180 full, and you already traversed C degrees, so you have to get the remainder basically. This angle over here has to measure 180 minus A for the same reason, because this is A, and this one, together they add up to 180. And this one adds up to has to measure 180 minus B, okay? For the same reason, right? So this angle and this angle, they have to add up to 180, okay? So we know that if we sum this angle, this one, and this one, the result has to be 180 because they are interior angles of this purple triangle over here, okay? So we know that if we take 180 degrees minus A, which is going to be this one, and we add it to, let's say, 180 minus B, which is this one, and we add it also to 180 minus C, which is this one, the result of that has to be 180 degrees, because all of those three angles are interior angles of the purple triangle, okay? So now, notice that we can take 180 and 180 is 360, and we can get rid of, we can get rid of this 180 with this 180 over here. So we're gonna end up with 360 minus A minus B minus C equal to 0. And then I can simply add A, B, and C on both sides, and I'm gonna end up with 360 equal to A plus B plus C. And that is my result, because we are interested in knowing or finding the sum of A, B, and C. Okay? Now another way you can solve this, and this is more visual, is that already you have two lines that are parallel, okay, which are these two, okay, parallel. So what I'm going to do is that I'm going to draw a line that goes through this vertex over here and is parallel to both of these lines, okay? So let's just say that I draw a line in purple like this, okay? And now I'm saying that all of these are parallel, okay? Now, if I do that, now I can think of this, maybe do it in a different color, maybe in blue. I can think of this line as a transversal of this one and this one, the first two lines that are parallel, okay? And if I do that, this angle is opposite interior to this one, so it has to measure the same as this one, so they have to be congruent, okay? So A, maybe let me do it over here, A has to be this angle, okay? We already know that B is this angle, okay? And if you notice, let's maybe do it in a different color, maybe green, or let's say yellow. If I think of the purple line over here and this one as the two lines that are parallel, and this one as one of the transversals, then this angle and this one are opposite interior angles. So this one has to measure C. So this one has to measure C. And notice how we have created a full rotation, a full circle. So that means this is a full rotation. So that means that A plus B plus C has to be equal to 360, okay? Which is what we found over here. It's just that we found it with a different strategy, okay? Okay, so I suspect that there are more ways to solve this problem. So if you can find a new way to solve this problem, please share it with me, okay? All right, so let's do the last one. So this is gonna be the last problem from your review. So in this problem, you have to show that opposite interior angles of a parallelogram are congruent. So remember that in a parallelogram, opposite sides are always gonna be parallel, okay? So let's just say that I start with this angle, okay? And what I want to show is that this angle measures the same as the angle in black. So let's just call that angle maybe A, Okay. Now I'm going to imagine that I can extend these two lines like this one like this one like this. Again, this always helps me to visualize what's going on. You don't have to do this, but it helps me at least. Okay. So if we think of this line and this one as parallel, which they are because we're working on a parallelogram, parallel, then we know that, let's see how I can approach this. Okay, so we know that this angle corresponds to this one, and the two lines, this one and this one, are parallel, so that means that this angle has to also measure A because they're corresponding, okay? Now, if you conceptualize now, or let me get rid of this part over here. Now I'm gonna view these two lines, this one and this one, as the parallel lines. And I'm gonna think of the one in yellow, this one, as the transversal, okay? So if I do that, this angle is going to correspond to this one, so this angle has to measure A as well. But then notice that this angle over here is vertical to this one, and we know that vertical angles are congruent, so that means that this one also has to measure A. And there we go. Opposite angles inside a parallelogram are going to be congruent. Okay? So I hope this helps. If you have any questions, don't hesitate to email me. If there is a problem that I didn't solve in this video and you want to see a possible solution for that problem, don't hesitate to let me know, and I'll see you in class.